Attendance enabled, guys. Mark your attendance, guys. It's open. Okay. Any doubts from the previous lecture? If you guys have any doubts, we can start with that. I have there were some emails that I was not able to reply back, but I have just replied back to your emails. So I hope that some of the doubts that you guys had are now resolved. But still, if there are any more doubts, let us start from there.
Sir, I have a doubt, but
Sure.
not related to the topic.
You have not?
Related to the topic, I mean,
Sorry, I didn't get your point.
sir, I have a previous doubt. Sir, I have a doubt that when I'm doing sir float a is equals to 2.00, sir, when I'm
Mhm.
doing C out, sir, it is printing 2, not 2.0,
Yeah,
sir. Why?
actually, the point is I'll have to read about cout's documentation. um, because it's not a part of C. If I am there, I might actually be offering a course on C++ next semester if I'm there. So I'm putting off uh, all the C++ related work currently because I have to go and read some stuff again. But basically, you'll have to see what exactly is the document. What does the documentation of cout says? Because so they just says that it actually truncates the zero. So I will have to go and read cout's documentation before I can comment.
Okay, sir. Thank you, sir.
Yeah, so that I think Tejas has already answered. I knew someone will probably already be in touch of C++. Um, okay, so Tejas knows the answer. Um, so yeah, there are some more suggestions on the chat. Vanshdeep, you can have a look. Okay, so let's just start straight away for the second part of the lecture on pointers. We can, I think this should be a shorter lecture, so we will have enough time towards the end for more discussion. Okay, and as I told you guys last time, I will not be looking at the chats when I give this live lecture. So if there is any problem, even if my voice is not clear or you have some doubt, you'll actually have to unmute and ask. There's no way I'll be able to check your chats. So and in the last lecture I also forgot to use laser pointer. Uh, it was pointed to me in the next session that I should have used a laser pointer. So I think you can see my laser pointer now. You can see where it is, where it is, right? So let's start. Okay. So what we already know till now. Okay. So we know that pointers are basically just another type of variable. There is something special about them. Instead of storing a particular value like an integer or a character or a float, pointers actually store addresses. That is the difference between them and, let's say, a regular variable that we've been using. And for even if they are storing addresses, there is always an associated data type, right? And this associated data type actually tells that this particular pointer is pointing to a memory location which is storing this type of data. Okay, so if I say int asterisk ptr, it essentially means that it is a pointer that is supposed to point to a memory location which is storing an integer. If I say double asterisk ptr, it essentially means that this particular location is expected to have a double value stored there. Now we can assign the address of any variable in C using the ampersand operator. The way to use it is something like this: you put a pointer and then you do pointer equal to ampersand and the name of the variable. This will basically assign the address of this variable to this pointer. And similarly, if you have a pointer which is pointing to a particular value in the memory, if you use the asterisk operator, asterisk basically takes you to that particular location. You can either read the value that is written there, or you can assign a new value to that particular location. We also saw that pointers, with pointers you can actually add integers to them. So you can, for example, add 1 to a particular pointer, or subtract 1 from a particular pointer. What it actually means is whenever you add 1 to a pointer, it essentially means that it is going to be advanced by a certain number of bytes. And what exactly are that, how exactly is it decided? It is decided by the data type of the pointer. So if the pointer, for example, is an integer pointer, and if you add 1 to it, what it really means is that advance the pointer to the next integer. That would mean adding 4 bytes to the current address. If it is a double pointer and you do a plus plus over that pointer, that is adding 1 to it, it essentially means point to the next double in the memory. So this means that your overall address will be updated by 8 bytes. So this is something that we already know. Okay, so now one of the most what can I say, important relationships in C and C++ is the relationship between pointers and arrays. Okay, and they are so closely related to each other that they are often talked about in the same context. So let's just make a simple revision. So we all know that arrays are essentially a collection of variables. Okay, and they are actually residing in the memory in contiguous memory locations, okay, one after the other. And if you want to access the ith element of the array, you use this particular expression arr and square brackets subscript, it's kind of subscript notation, and then you do this I thing. However, when you actually write something like this arr square brackets I, the compiler, what really happens in the background is that the compiler converts it into asterisk ARR plus I. This is what happens. Okay. Now you can understand that essentially this ARR is nothing more than a pointer. So what happens is, this ARR is essentially a kind of pointer constant. It is not a pointer variable because you cannot change the pointer to something else. So for example, a regular pointer, you can reassign it to something else. With an array you cannot do that, so ARR cannot be reassigned, it remains exactly the same. So it is basically an address, but it is, as I said, it's kind of a pointer constant and not really a pointer variable. Okay, and what ARR really does is that it actually points to the starting address of that allocated space. So if you have created, let us say, an array of ints, and let us say you have created a 5 element int array, it means that 20 bytes of data would have been would have 20 bytes in the memory would have been reserved for you, and this ARR is just pointing. Okay, it is a pointer which is pointing to the initial address, the beginning of these 20 byte block. So for any given array, you can always interchange this notation with this notation. The compiler will not complain. This is the idea. If you change ARRI with this value at ARR plus I, the compiler will not complain, because in essence this actually gets converted into this before being evaluated. So, ARR is just an alias. It's another name for basically this expression, ampersand, that is address of ARR0. So ARR0 is basically the first element of your array, and the address of the first element of the array is also the starting address of the array. So basically ARR is just an alias for this. Therefore, if you create a pointer called p, which has to be compatible as in, if ARR's type is int, this should also be int asterisk. If ARR's type is, let us say, double, this should be double asterisk. So basically there has to be a compatibility between p and ARR. As long as they are compatible, you can do something like this: p is equal to ampersand ARR0, or you can simply say p equal to ARR. Why? Because ARR, as I told you, is just a pointer constant. So this is actually nothing more than an address in the memory, and you can actually assign this address to the pointer variable. So now, from if you do something like this, p will start pointing to the same location. It will start pointing to the starting address of this array, and from there onwards, if you write something like this instead of this is perfectly legal. Okay, so from there onwards, you can use this pointer p as if it is an array. Okay, and you can write something like this, the compiler will have no complaints with it. The difference between, of course, p and ARR is, as I said, ARR is not really a variable. It's kind of a constant. So you cannot do you cannot add one to ARR, for example. Okay, so ARR plus plus is not a valid statement. However, p is a variable, and you're allowed to do something like p plus plus. This is perfectly fine. Um, so if you see this particular example here, I have created a character array. Okay, it's called hello, and then I'm creating a character pointer. So this is what I was saying, that they are compatible with each other. This is a character array, and this is a pointer to a character. They are compatible with each other. And then what I'm doing here is I'm simply saying, let this pointer point to the starting address of this particular array, right? So this is what it is doing. Hello, as I told you, it is just an alias for an address, and that address is the starting address of this hello array, which, by the way, is equivalent to writing this as well, right? So you can actually, I should write char asterisk, right? Uh, so char asterisk hptr equal to ampersand hello. This is the idea, hello 0, that you can assign the address of the first member of the array to hptr. This is equivalent to writing it like this. And then from there onwards, whenever I'll just do a plus plus, plus plus will mean that move to the next character like this. Okay, of course, because character is just 1 byte, this will take you, this will just add 1 to the address that is pointed out by hptr. But had it been, let us say, int or double or float, this hptr plus plus would have meant adding 8 bytes or 4 bytes, or whatever is the size of that particular data type. So here, as I said, this particular loop is equivalent to this loop. You can actually do I equal to 0, arr I is not equal to the null character I plus plus, and then you just print the ith character of the array. This loop and this loop, they are actually equivalent to each other, right? So essentially, this hptr now can be used to browse through the array like this. And the pointer arithmetic that we learned in the previous part of this lecture, you can see how that same pointer arithmetic can be used to browse through an array like this. And this, of course, just prints a hello world. Okay, any questions still here?
Sir, can you please explain which one is the address and which one stores the value?
So ARR is an address here. ARR is basically an alias for some address in the memory, and hptr is a variable. It is a pointer variable which can store many addresses. Okay, so it's like an integer variable. So when I say int um, I can store any integer value, right? In fact, let me just change it right here, because otherwise it will be confusing for so many of you. This is like this, this is equivalent to this. Okay, um, char asterisk hptr. Otherwise, I will write something like this. And let me add this here. Or hptr equal to ampersand hptr equal to ampersand hello 0 this. Okay, so this is what it is. So essentially, hello, is a character array, but at the same time, this, as I said, this character array is nothing more than a constant, a pointer constant. It is essentially a address in the memory, and this hptr is a pointer variable. It can point to any address in the memory, which is essentially a character, which is actually a character, right? So char asterisk hptr essentially means that it is going to point to a character. Now, this hello 0, right? This is essentially just one character, because I have put 0 here. So it is not the array, it is the 0th element of the array, which is again a character. Its address, okay, let me just bring the laser pointer back. So this hello 0 is one character. Okay, its address can be assigned to hptr. This is valid. And I can also write something like this, because hello by default, it will actually point to the first element of the array anyhow. Okay, so essentially this, as I wrote, um, arr is equivalent to ampersand arr 0. Okay, address of the first element of the array. Wherever you are writing this, you can also write simply arr. This is the idea. Okay? So arr is the pointer, and this arr is a pointer constant, and hptr is a pointer variable. Okay, does it make sense? Any more clarifications for this? Any more queries? So you guys understand what is happening here? Essentially, we are we are basically taking a pointer to the same location where hello starts. Okay, so hello is going to have how many characters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and the slash 0, 15. So this is basically 15 bytes of contiguous memory, uh, which hello points to. And then with this statement, HPTR starts pointing to the starting address, of that 15 byte block. Okay, so and from there onwards, if I do HPTR plus plus, because its type is character, each time it will go 1 byte forward, and I can actually access that particular location, similar to accessing the arrays element using the ARRI notation. Okay, is it clear now? Any more questions or clarifications? Okay, so let's just move forward then. Now, till now,
Sir,
what
the HPTR plus plus, it is showing the sir address plus plus or the value plus
it is
plus.
address plus plus.
Okay, sir.
You are just adding. So this is pointer arithmetic. This is not value arithmetic. This is pointer arithmetic. Any more questions? Okay. So, till now, whatever we have seen, it has, from the perspective of utility, right? We have not really seen any utility of pointers, because whatever we saw, that was just an alternative way of doing something that we could already do, without the use of any pointers, right? So we haven't actually discussed a single reason about why, in what situation, in what condition would pointers will probably be handy, right? So there's at least one that we talk about now. There will be one more that we will talk about when we discuss functions, and there will be probably another one that we will talk about when we'll discuss structures. But today, let us just talk about one of them. So when we were discussing arrays, I told you that in C, actually this is not allowed. I mean, if n is a variable, if I declare an array like this, um, this is something that was not allowed essentially initially. Maybe in the later versions of C it could have been added, or maybe it is just something that modern GCC compilers may allow. But the standard C, that from where we started off, it this was actually illegal. You cannot provide a variable as a size of an array. Okay, you had to provide a constant, something like this. And that is why the code that I send you guys, I never use a variable there, because just for the sake of backward compatibility, if you run that code on an older compiler, it should work as well. So you can define a constant using something like hash define. We are not discussing hash define as yet. We'll discuss it maybe at the end of the course. But the idea is, the capacity of an array must always be declared using a constant. This is something that we have seen till now. But in certain situations, and what this means is, many a times we actually have to declare an array to be of sufficiently large size in order to do our work, because we really don't have the option to pick the capacity of the array randomly during when the program is already running. So there is a function, a library function in C. It's called malloc, or malloc, as we often call it. What malloc can do is, it can actually allocate some dynamic memory for you. What I mean by dynamic is, the static memory is the memory that, the opposite of dynamic is static. So the static memory that gets allocated to a program is the memory that is allocated when you declare some variables, define some variables, right? If you write int I equal to 5, or float f equal to 4.5, some memory gets allocated for these variables, right? This is something that happens in the background. But sometimes, as I said, when, let us say, I want n bytes of data of memory, and the n is being inputted to me by the user. So for example, before doing something like this, I'm actually doing a scanf, and I'm asking the user to give me the value of n. So this is not possible. This was at least in the earlier versions of C. Um, and many a times, you, even if it is possible, many a times you still want to do this on the fly. So in such cases, there is an option for allocating memory dynamically, and this option is called the malloc function. So how does the malloc function works? You simply give the malloc function an argument which says how many bytes of dynamic storage do you require, and malloc will actually allocate some space in the memory for you. The
Sir,
space will be, go ahead,
hello.
go
Is
ahead.
this dynamic memory allocated in the heap?
Yes, it is allocated in the heap. I'm not talking about heap and stack because people don't understand what is a stack and what is a heap. So as of now, let's just assume that it is allocated somewhere in the memory.
And so this malloc returns a pointer or
Yeah, yeah, it returns a pointer.
okay.
It returns a pointer. Okay. So basically, there is a block of space allocated for your use, and malloc returns the pointer to the first location of this block. Okay, so if I want 10 bytes of data, which, let us say, which starts from address 1000 and goes up to address 1009. Um, malloc will return a pointer that points to location 1000. So this is, so the idea of malloc is that if I want to create an array of variable size, for example, I want to create an array of size n, where n will be different when my program executes different times, uh, or what I really have to do is something like this. um, Whatever is the size of my array, for example, the size of the data type that my array is supposed to be. For example, if it is an integer array, it will be 4. If it is a double array, it will be 8, something like this. So I simply multiply that by n, and these are the number of bytes I require, and I just pass this to malloc, and malloc allocates the requested amount of memory, and it returns a pointer to the first element, at the starting point of that particular block of memory. We can then use this return pointer similar to an array. I'll show you what it means. There is a drawback though of this. Now whenever we use these variables, we know there is a concept of block, right? Whenever you create a variable inside a block, its scope is within that block only, right? This is what we have discussed before, that as soon as you exit that block, that variable is no longer available to you, right? So what really happens is, the memory that was allocated for that particular variable is essentially freed as in, the memory is no longer. Does anyone has a question? Okay, so when the control moves out of a particular block, all the variables whose scope was limited to that particular block are now essentially out of scope. You cannot access them anymore, and the space that was allocated for these variables can now be reclaimed and used for some other purpose. But this is not true with malloc. Okay, so even if, so let us say you created a pointer inside a small block, and now you have already exited the block, you might feel that the pointer is no longer accessible to me, and hence whatever memory I allocated, it is now free. It can be reclaimed. No, that is not possible. This is the drawback of using malloc, that whatever dynamic memory you allocate using malloc, it has to be explicitly freed. Okay, explicitly freed by using the using another library function called free. So what you do is the same pointer that was returned to you by malloc, that has to be provided to the free function after you have used the space for your purpose. You know, you might have used it for some purpose, but once you are done, once you no longer require that space, you'll have to free it explicitly. So that is the drawback of using malloc. The memory allocated via malloc is not automatically freed. So this is a simple example. Um, you guys might have already used this toUpper function. It takes a character and simply returns the uppercase character for this particular character. So this program is just trying to be a toUpper function, not for a character, but let us say for a word. So again, I mean, you don't really need a pointer here. I'm just trying to show you how malloc works. So this is what I'm trying to do here. I start by creating a character pointer. This is char asterisk. This means its idea is that it is going to point to, and you can see something like null here. Null as in null in capital. So when we use pointers, you remember that whenever we declare a variable in C and we do not initialize it, what happens? It gets some garbage value, right? The same thing is true with pointers as well. If I just leave it like char asterisk characters semicolon, um, the value that this particular pointer will be it will be having, the address to which this particular pointer will be pointing to will be some random address in the memory. Okay, and we also call such pointers as dangling pointers. They are pointers which really we don't really know where they are pointing to, or they are pointing to a invalid location, something like this. So there is a facility that C provides you. It's called null. Null is a special constant. You can actually initialize your pointers with null. If you initialize it with null, it is kind of a convention. It means that this pointer does not point to any location. It's kind of like that. Okay, so null is probably the equivalent of zero. It is in fact zero. On the background, it is actually address zero. So basically, the idea of using null is a kind of good practice that you don't leave out dangling pointers. Anyhow, so basically this is a variable called characters. It is of type char asterisk. This is from where we start, and then we use a malloc. Okay, and in malloc, what I'm trying to do is I wanted uh, to create space for storing these many number of characters, and plus I need one for the null character. So this is the number of elements I want in my array, and this is a good practice. Okay, instead of writing one, even though I know that character take 1 byte of space, it is a good practice of using sizeof at this place, right? Because at least there is a possibility for that for different data types on different platforms, you might have a different size. So for example, int might be 4 bytes on GCC platforms, but it may be 2 bytes on the Turbo C platforms. So it is always a good practice to go with sizeof instead of writing things like 1, 4, or 8 here. So the idea is when you are trying to use malloc, here you basically put the size of the data type. So if you want to create an int array, you will put size of int here. If you want to create a double array, you will put size of double here, and then you multiply it by the number of elements that you want in your array. So here I'm asking for these many number of elements. From here onwards, this characters pointer, it can be used in exactly the same way as you use an array, right? So now this particular notation, characters I, is a perfectly valid notation. Okay, the compiler will not complain at all. So essentially, I'm now using this characters pointer like a dynamically allocated character array. Okay, so this is one simple use of pointers where you use them for dynamic memory. Of course, with the in array, I think the modern compilers anyhow allow you to use a variable in the as the size of the array. But we'll see that we'll actually need these kind of dynamic memory allocation in many scenarios. Okay, so there is a data structure called linked list. Um, we'll probably just discuss it towards the later part of the course. There you actually do not know the size of the array beforehand. It has to be dynamically allocated. So there this malloc function will be very useful, and the pointers will also be very useful. So but this is just to give you an idea that how malloc is used, and then how you can use a pointer in a fashion as if it is an array. And once all my stuff is done, right before my program ends, I've written this free function. So free function is taking the same pointer where my allocated memory was being stored. The pointer to the allocated memory was being stored. I simply pass it to free, and this free function deallocates whatever memory was allocated to me. Now, in a large program where you are doing a lot of allocation, if you actually forget using the free part, um, it might actually result into a scenario called memory leak. So what memory leak? I mean, memory leaks are essentially the cases where you keep on leaking memory. Leaking as in you keep on allocating memory, but not freeing it. So at some point of time, you will run out of memory. Okay, so there will be no more memory for malloc to allocate you space. So this is very important. Whenever you write a malloc, there has to be a matching free statement. Okay, this is kind of necessary. If you don't do that, you are risking memory leaks. Okay, any questions still here?
Sir, if I don't use the free
Mhm.
function, then sir, if I check my system memory, sir, will it be reduced
Will it
permanently
be?
or not?
No, it's
Will-
not like that. The as in fact, in this particular case, free was anyhow not required, because as soon as the program ends, all the memory that was allocated to your program is anyhow freed. um, this free is important when you are running a large program, and let us say you are allocating memory in a loop. Okay, this loop is probably going to run thousands of times, and you're thousands of time you are going to allocate some new memory. And if you are forgetting to free it, it might be possible that when you run it the thousandth time, there is really no more memory to be given to you. So this free is important within the context of the program only. Once the program ends, then everything is freed.
Yes, sir. Thank you, sir.
Any more
Sir, can you
questions?
can you explain the syntax of malloc?
Yeah. So malloc syntax is very simple. It just takes one argument. Okay, and malloc's it takes just one argument. I have written this expression so that you can understand what exactly is the value being given to malloc. But malloc just takes one argument, the number of bytes you want. Okay, now the idea here is, if I want to create an array of size n of a data type, let us say called x. Okay, how much amount of memory do I need? I need size of x multiplied by n, right? So if size of x is 4, I need 4 n bytes. If size of x is 8, I need 8 n bytes, right? So the idea here is I'm just calculating the number of bytes I need, and if you write it like this, it is easier to understand, right? So it is, when you're reading the code, it is easier to understand that exactly what is happening. So you can basically, by seeing this statement, you can understand that I want a character array which is going to be of size character underscore count plus 1. But you don't really need to do that. You can actually calculate it prior to this statement, and simply give an integer to malloc. So malloc just expects the number of bytes that you want. That's it. Any more queries? I just have one more thing to discuss. In fact, this is not directly related to pointers. This is something that we have been avoiding for a long time. Um, in the beginning of the course itself, I told you that whenever you write a C expression, the expression is evaluated from left to right, right? I told you that there might be some exceptions to this rule, um, but for most cases it will be left to right. So now that we have studied pointers, I'm just going to tell you what those one of the most important exceptions to this left to right rule. Okay, so remember those two operators that we have seen, the pre-increment and post-increment operators, the plus plus I and I plus plus operators. Now this is what is different with them. The the pre-increment operator as well as the asterisk and ampersand operators. Okay, these three operators have a right to left associativity. Okay, so they are evaluated from right to left. So what does it really mean is that if there is an expression where you have both of these operators, asterisk as well as the pre-increment operator, um, and by the way, both pre-increment operator as well as asterisk have the same precedence, but the post-increment operator has a higher precedence than both of them. So let's just talk about the pre-increment operator. When you have an expression like this, plus plus asterisk ptr, so there are two operators here, plus plus as well as asterisk, and there are two operators here as well, asterisk as well as plus plus. These two expressions are not the same, even though I told you that usually when you do not have any other operator there, when you're not using plus plus in a complex expression, it doesn't matter whether you write plus plus I or I plus plus. But let us say i's address is stored in ptr. You might feel that plus plus I and I plus plus are equivalent, then plus plus asterisk ptr and asterisk ptr plus plus are also equivalent, then no, that is not the case. Okay, in fact, this is what happens. If you write plus plus asterisk ptr, it gets evaluated like this. Why? Because these operators have right to left associativity. So what I mean by associativity is something like this. If the compiler finds two operators of the same precedence in an expression, the associativity decides which of them will be evaluated first. Okay, so if the associativity is left to right, the first operator is evaluated first and then the second one, and if the associativity is right to left, the second operator is evaluated first and then the first one. So this is why, if you write plus plus asterisk ptr, this is equivalent to putting asterisk ptr in a parenthesis and doing plus plus. And the interpretation of this is that increment the value which is stored at the address pointed by ptr. So this asterisk ptr will take you to that location where it was pointing, and then a plus plus means simply increment the value that is there. Whereas if you write something like asterisk ptr plus plus, it is evaluated like this. The ptr plus plus is evaluated first and then the asterisk is evaluated. Why? Because the post increment operator has a higher precedence. So this is evaluated first. So this can be interpreted something like this. um, Advance the ptr by 1 unit and get the value at that address. And so essentially ptr plus plus is just advancing the pointer, right? This is similar to h ptr plus plus that we saw in that code. So ptr plus plus is just advancing the pointer, and then when you do an asterisk, it simply means get the value at the advanced location, the next location. And just a reminder, this is something that that might be confusing for you, that how do I remember which operators are left to right and which operators are right to left. One what I can say, one relief is that all the operators which have the same precedence, they also have the same associativity. So you will never come across two operators which have the same precedence but have different associativities. Associativity is basically attached to a particular precedence level. So the idea is that asterisk, ampersand, and the pre-increment operator, they are at the same level of precedence, whereas the post-increment operator is higher than these guys. And it's the post-increment operators has an associativity which is left to right, the regular associativity, whereas these guys have associativity which is right to left. Okay, so this is not really something related to programming. This is a discussion that we have avoided for a long time. So I just wanted to show you the exception to the left to right rule. So once we have understood the pointers, there is a very compelling case of understanding associativity. But again, I have given this statement before as well. Don't worry too much about operator precedences. You can always use parenthesis wherever you are in doubt that I don't know whether this operator will be evaluated first or that operator will be evaluated first. Simply use a parenthesis. That is the safe way. Okay, if you are not clear about operator precedences, always use parenthesis.
So both are storing the value in, sir.
Pardon?
So both post and pre, sir, they both are storing the value here, na?
So this is the idea. They are actually entirely different. The way they are happening is entirely different. This plus plus is increasing a value, and this plus plus is advancing a pointer. This is the idea. Okay, in this context, they are entirely different. Okay, here this plus plus is going to increment the value which is stored at this particular pointer. Okay, and here the pointer is being advanced to the next location, and then whatever is at that particular location, it is read or used. Okay, so here the difference is that the plus plus operator, if it is used in the pre-increment form in this expression, it will actually increase a particular value, whereas the plus plus operator in the post increment form is actually advancing the pointer to point to the next location. Okay, any more queries?
They have the same answer, na, sir?
No, it is different. It is going to be I mean, first of all, this is, as I said, right, let us say I have written something like this. Shall I open up mm, shall I open up some new slide? Okay, let me just add a new slide here. Huh. So let's say it is something like this. I equal to j equal to 5, and let us say I have int asterisk ptr equal to ampersand of j, right? And let us also assume that j is stored at address 1000. Okay, now what exactly does ptr contain? Come on, PowerPoint, don't do this. Not sure what's happening. Basically, let us say a j was allocated a space at address 1000, and now ptr is pointing to 1000. Okay, now if I do this particular expression, what does it do? It says go to this location, whatever is the value. So in the parenthesis, you will have 5, and plus plus means increase it by 1. Okay, so then this particular value of j will become 6. Let me call it here, write it here.
I got it, sir. Leave it, sir. Got it.
You got it. And this one is entirely different. It will basically go to a different location in the memory, and whatever is there, it will fetch it. Okay. Okay. Uh, so let me just go back to the chat part. Yeah, go ahead, guys. So there are some lot of chats here. Yeah, go ahead. Any questions?
Sir,
Malloc.
Yeah.
sir, if I define an array and then input values in it,
Mm-hmm.
and let's say the array was of 5 elements, and
Mm-hmm.
then I write free array of let's say 2, index 2.
Mm-hmm.
Would it delete the element or would it corrupt
No,
the
no, no,
array?
no. No. So basically, nothing will happen. So free, it can only work on dynamically allocated memory. Okay, it doesn't work on arrays. uh, Free can only free the memory that was allocated via malloc. There are some other siblings of malloc that is there in your homework. Okay. Things like calloc and alloc a. But free can only free the memory that was allocated dynamically. It cannot free a memory which is created, which was used by an array. So your statement free arr2 or something like this, that won't work anyhow.
So say if I define an array using pointers using malloc, and then I can use free.
Yeah, then you can use free, but even then you'll have to give the pointer itself. Arr2 will not have any effect at all. I don't know whether it will give you a warning or not, but free arr2, or it might actually result in some kind of a runtime error. But free arr2 will not work. Okay, only free arr will work. That is the idea. Because what happens is, whenever malloc allocates some memory to you, uh, it is actually slightly more than what was asked. So for example, if I asked for 5 bytes, it might actually allocate 6 or 7 bytes, something like this. Okay. Some 1 or 2 bytes of memory is used for bookkeeping, as in, when you return, when you give this pointer to free, internally it knows how to figure out the size of this block. So if you actually give it an address of the second location or the third location of the block, that will not work. It has to be the initial location from where your block starts. So that is why free ARR only can work. Free ARR2 will not work.
Okay, thank you, sir.
Hmm. There was
The
one more
malloc
question. Yeah, go ahead. Go ahead.
returns a integer pointer. So why we need to explicitly convert it into int star before storing it
Mm,
to a variable?
where I am converting it, I'm not sure.
No, I tried, sir. I tried like this: int star point p is equals to malloc size of int into 4, and then I executed it. It was saying use int star before it, and then I
Mm,
used it.
see,
So it was
Yeah, so see, idea is like this. Malloc, I mean, here I am not using because it is not really, it should not be required in the modern compilers, but the way you are telling this, that is actually the proper way. In fact, I should have, it is probably my mistake. I should have written it like this. I'm typing it in the chat. So ideally, I should have written it something like this: characters equal to char asterisk malloc and blah blah blah, whatever it is. Okay, whatever is there inside the malloc. Why we should do it, this is by the way the preferred way. I think I should add a note in the program. I'll probably change the program itself. I will write this char asterisk in the program as well. Anyhow, why do we do this? It's like this. When you actually ask malloc for memory, you don't really tell malloc how are you going to use it. Okay. You just say, I need these many number of bytes. Okay, so if you create a 20 by, if you want 20 bytes from malloc will give it to you. Now 20 bytes could mean a character array of size 20 or an integer array of size 5, right? You can use it either way you want. So if you want to use that pointer later in this particular fashion, um, let me, where is the Can you guys see my mouse pointer? No, right? Um, uh, so you can see, right? So if I want to use it like this, okay, characters I, to do this, um, the compiler must know what is the type of characters. So that is why, I'm not sure why it is giving you a warning. I was not getting any warning, but that is the proper way of using malloc, by the way. We should do a typecasting, an explicit typecasting of that memory location, um, to tell the compiler that I'm going to use this memory location for integers or characters or double or whatever it is, because malloc just returns you uh, a space, a block of space. It is up to you how you use that block. You can use it for storing characters, doubles, integers, whatever way you want. Okay, so when you do this typecasting, explicit typecasting, then the compiler knows that, okay, you are going to use it for this particular purpose only. Okay, so that is why I should probably add this char asterisk in the program, so that it is not confusing to you guys. Um, but anyhow, read about malloc, anyhow, read malloc and calloc. Um, the point is they actually allocate the memory in a block. It's up to you how you use that block. Okay. Any more questions? There are so many things in the chat. I'm not following what happened. Are there any questions related to this? And for me, please ask. There are so many things I cannot read all of it. Okay, vectors. Uh, yeah. So any questions? Please ask me. I probably won't be able to read the whole of the discussion anyhow. And now we have to make a call on two things. One is Microsoft Teams. So any one of you, I think Tejas, you were there, right? Who has tried out Microsoft Teams. So please do guide me what exactly is supposed to be done. I tried to create an account, but you know, Microsoft scolded me that you are not allowed to. So please tell me what should I do? Shall I create an individual account, or how does it work? What exactly are the things that you guys tried? So please tell me. I'll have a look at it over this weekend. If it works out, it will probably use Teams from the next week. Um, and uh, Otherwise, we'll have to stick with with WebEx. This is one, and the other one is, now you have to decide upon live lectures versus recorded lectures. So you would have understood the pros and cons of a live lecture as well. First of all, the content this week was anyhow smaller, so maybe I also had a little more space for discussion. Because I did not want you guys to dive too deep into pointers, because pointers is something that a lot of people dread. They don't want to use pointers. They are scared of pointers. But I had to cover them, because if you tell someone that I'm a C++ programmer, um, that person would expect that you can teach him or her pointers. So at least the basic concepts of pointers should be clear to you. And this dynamic memory allocation, um, you guys have a course on data structures, probably in the second or third semester. These pointers are going to be very very handy, because in data structures, especially in linked lists, um, you cannot survive without pointers. So you at least need to know uh, how pointers work. So this is why I have covered pointers. Don't get too much worried. Pointers is a world of its own. There are so many things that I could teach you just in pointers. Um, but what you should do is that there is a chapter called pointers and arrays in your C reference book, okay, by Cunningham Ritchie. If you get some time, read that chapter. You'll get because now you know about arrays as well as pointers. If you read that chapter, you should understand. Okay, and that. Oh, sorry, I probably there was a question on the chat. What is it? Aditya, for me or were you answering
Yes,
someone
sir.
else? Okay, sorry.
No, sir,
Let
for
me.
you.
Oh, sorry. Let me, because I didn't check the chats. Just a minute. And n equal to 4 and asterisk 2 equal to ampersand and printf slash n asterisk p plus plus return 0 is the same value as 4. Um, asterisk p. Yeah. So this will be basically, yeah. So what happens is that that p is actually going to point to the next location. Int n equal to, it is storing the address of n, right? And asterisk p, uh, it should not give you 4. The idea is it will actually start pointing to the location that is right next after n. uh, so I'm not sure why your next, it could be possible that the next location also has the same value as 4. um,
So maybe it's like its address has been changed, but its value is same.
its address has been what? See,
Its address
pointers,
has
it's
been
like this.
increased.
Yeah, so actually, this is how I interpret these questions. So let us assume that n was assigned at location 1000. Okay, so now what is it that is stored in p? P has the value 1000. Okay, the way this will be evaluated is something like this. Because int takes 4 bytes of space, p plus plus will now start pointing to 1004 and value at 1004. Now frankly we really don't know what is the value that is there at 1004. Okay, so that is, so, it might be 4, but it, it should not have been 4. It should be something else in my view. It is giving 4.
Sir, but sir, I matlab run the code, sir, but it is giving 4, sir.
Okay, see, the problem is, maybe I'll have to check it out. There are some ways to it. It should not be garbage value. My best guess it should actually start pointing to the variable
Yes, sir.
p.
I also expected for the same.
Yeah,
Uh,
right. Uh, okay, I'll probably run it in GDB. I'll have a look what it does. So GDB is the debugger for C. I'll probably just run it in GDB and have a look. It is giving core dumped. Okay, so for Prabhav, that is the idea. It is giving core dumped. And this is what I am also assuming, that it, maybe it was just a fluke that it was 4. The 4, 4 was also stored at the next location, the next integer. But ideally it should not, it should, I mean, it should do something unexpected. This is the idea. We should not be able to to uh, oh, sorry, by the way, this is as p plus plus, right? uh yes, do this. Don't print this. Do this. After this, put another printf statement, and then print the value that is there in p right before this printf statement. This and right after this printf statement. The actual value that will be changed will be of p, not the value of that particular location. That is why it is 4. So this is what happens. Plus plus is post increment, right? So it will happen later. Okay. So this is the idea. Yeah, the output is absolutely correct. What you should do is do this: add 2 more printf statements, one just before this printf statement, and give percent p, and then print the value of p, and then put the same statement. This is the printf I'm talking about. Mm. Just add this statement before and after the printf that you have given. you will see the change in the value of p. That is what that is what is happening. Okay, this is what no, Sanskriti, it is exactly right. I didn't realize it is post increment. So post increment would mean that the same value of p gets used there, and then it will be the actual value that gets changed here is not the value of what is the variable, not the value of n. Okay, the value of p gets changed. This is the idea. Okay, just add this printf statement before your printf and after your printf statement. Yeah, that is the idea. Just like this. Just before and just after. You will see that the actual value that gets changed is the value of p and not the actual value, right? And the value of, yeah. So yeah, so it should, that is the idea. The address will change because, and in fact, let me go back to the slide again. Where is that slide? Mhm. Yes, this is the slide, right? So this is what it says. What happens in this particular case? Advance PTR by 1 unit and get the value at that address. Oh yeah, this is wrong. I should not say at that address. That is essentially, the address that PTR was pointing to. I should write. Not that might actually mean that it will get the value at the advanced point. Yeah, this is wrong. Let me write it like at previous address. Okay, is it clear now why it is giving you 4? It is post increment. What happens with post increment is, post increment basically means use then change. Pre increment means increment then use, right? So the idea here is that in this case you are actually advancing the pointer, you are incrementing the pointer, and in this case you are incrementing the value. Okay, is it clearer now? I should change it to previous. This is my mistake. I should have written previous. Um, so, but can you guys understand what happened in this code? So this is like this. This particular statement. This gets evaluated like this. So essentially, it says evaluate p plus plus first. Okay, first as in, so whenever I write plus plus, it means use then change. So what happens is like this: your compiler um, places p here instead of p plus plus, and in some fashion, when as soon as this statement gets over, p is incremented. Mm, like this, right? So p gets replaced by p plus plus gets replaced by p, and then p is incremented. This is the idea. Whenever I do p plus plus, this is the same as I plus plus j plus plus, whatever it is. Then what happens? Then this gets evaluated. Asterisk p. What is asterisk p? The previous location where p was pointing to, and that is 4. But right after this value 4 has been returned, p is incremented by 1. Okay, is it making sense? Who gave this code? Aditya, right? So Aditya, can you
So,
understand
sir,
what is happening?
so sir, when I use further its value, would it work as 5 or 4?
This is 4 only. It will be 4. Your n's value will be 4 only. You
Yes,
can
sir.
you can printf. You can also put a printf here. Which prints the value of n before and after this statement. Okay, check it up.
Yes,
It should be 4 only.
yes, sir.
Because this is the idea that when you do this, when you're using the post increment operator, you are essentially incrementing the pointer. When you're using the pre increment operator, you are incrementing the value gets incremented. This is the idea. Okay, any so I just like, is it clear to have? Okay, we have short the time as well. Do you have a class right now? Okay, so is this part clear now? The post increment and pre increment. The idea that I told you guys about it is that whenever you are in doubt, just use parenthesis. This is the idea. uh, and especially when you are doing pointer arithmetic, just use parenthesis to be absolutely sure that what happens is exactly what you want it to happen, and you're not in for some surprise, right? So for example here, the value of n will remain unchanged, even if that was what you wanted to do, right? uh, and please check it out. The value of n should be uh, should be unchanged. Okay. Any more questions, guys? And by the way, you okay, I'll talk about that later. Any more queries related to this, or we'll just yeah, I was talking about live classes versus recorded lectures, and Microsoft Teams. What uh, okay, what
Sir,
exactly is, yeah, go ahead.
I ran this code. So this what is doing is first it inputs an integer n, then it makes an array of n integers, and then it inputs the value in the integer. Then I
Mhm.
define a integer to the array. I'm displaying the that pointer p such that it is not equal to null, and it will print out the in position of that pointer. So sir, when I execute it, it is endlessly showing numbers.
uh, First of all, I'm actually losing you in between. Just send this code to me over email. Okay, I'll have a look, because right, because it's actually hard to read it in chat. So,
This WebEx,
and your voice is also
Yes,
breaking
sir.
up. So just send it to me over email. Uh, yeah. So please, whomsoever is an expert on Microsoft Teams, please send out an email to me and help the class. uh, we'll see if we can use Teams. If that we can do that, that will actually be very good. I also hate WebEx. um, but otherwise we will be meeting on WebEx only in the next week as well. Next week there will be a lab as well, that will be based on, okay, we have actually covered a lot. Let's just say it will be based on loops. Okay, I'll just give you some loop questions. um, Nothing from pointers. Okay, before pointers, that the lab will be based on everything before pointers. So and what else this was on? Yeah, please select your choice of teaching, live lectures versus Shreya, right? Shreya, are you in this batch, or in the other batch? I just keep forgetting. So I have given the responsibility to Shreya to send out another one. Uh, yeah, see, Aditya, I don't have a problem. The only problem is, maybe this week the content was. Oh yeah, yeah, yeah. I'll do that, Mohit. I, as soon as I get it from Webex, uh, I'll do that. I'll do it by evening. Sometimes it gets late because I something happens on the personal front. I have to. Uh, it's up to you guys. Up to you. Like, you have to decide. It's let me tell you that effort wise, this is better for me, because recording those lectures take up more time. I have to spend more time over the weekends in recording. uh, in live
Yeah,
lectures.
sir.
Yeah, go ahead.
Sir, I have no problem with live lectures, but sir, I would ask that you upload the videos of the recordings daily, after every class, that day only. Because if
Yeah,
like the class is on Monday and you miss out something,
got it.
and the recording
Yeah,
is not there, then the
I
Tuesday's
think on
class will be
Monday,
like,
I think on Monday I did upload it on the same day. Um,
yes,
and
sir.
right, so I'll try to do that. There is no issue with that. I can do that. It doesn't take that much time to upload the lecture. Um, The major issue is to record them. Uh, so anyhow, yeah, I will do that. Maybe, my family is calling me for lunch. As soon as I'm done with my lunch, I'll upload lectures for both the sessions. Yeah. So by the way, do you guys have to decide upon this? Okay, just you know uh, do do some kind of polling between yourself. That I don't even need to know the Google form and everything. You do your poll on WhatsApp. Have a discussion on WhatsApp groups or whatever it is. I just need a final word from the batch, that whether you would like live lectures or and batch as in both batches. I can't do live lectures for one and recorded lectures for others. So it has to be the same for both batches. So talk among yourself and come up with a solution, and tell me. But make sure that a good number of people pick the same solution. If it is like a 45-55% thing, then I will pick my own solution. If it is 70-30, then yes, whatever you guys say, I will agree to it. And I don't want to take this decision. Let me be very frank. I don't want to. I just expect you guys to take this decision. Okay. So let's just break. We'll meet next week. Before and
Sir,
go ahead.
sir, next week lab will be on loops only or before pointers, everything.
What did I teach in the uh, so what was our syllabus after the loops? What did we cover in the
Arrays and strings.
Yeah, it will be there. It will be there. Okay, as arrays and strings will be there as well. Okay. Yeah,
Okay,
so
sir.
everything before midsem. Let us say this. Next week lab will be everything on everything before midsem. Okay. Okay, so let's break, guys. We'll have a lot of emails over the weekend then. Okay, we'll have conversations over the weekend through mails. Okay, guys. Bye.